Chemistry Week 10 CA. Which of the following are common characteristics of the nuclei of the same element? Here they said the nuclei of same element. Now علشان same element, they're going to have the same number of protons. The number of neutrons can change in isotopes, and number of electrons can change in ions. The same element, the only thing that stays the same is the protons. So, same number of protons and same nuclear charge. The charge of the nucleus, not the whole thing. Same number of electrons can change. Same number of neutrons, they can change كمان. same number of nucleons لا علشان nucleons depend on the neutrons and protons. Question 2. Which of the following statements are true about ion formation? Now ion formation, we have مثلا imagine this is the atom. When we want to take one electron out, we need to put energy into it, and then that energy is absorbed into the electron here. So we have E minus plus E minus plus energy. So the energy is absorbed. So we took the electron away, so we formed sorry, this isn't here. So we took an electron away from a balanced atom. So now it's only the nucleus in there, so it's positively charged. So energy is absorbed when positive ions is formed. And then in a negative ion, we have this مثلا we have the electron alone with the energy absorbed in it. When we bring it close to the positively charged nucleus, the energy is going to release and it's going to get attracted. So released when negative and absorbed when positive. Which of the following is true about electrons in an isolated atom? Electrons are not found in the nucleus, and they have no orbits. They move randomly. They vibrate back and forth in fixed positions, not in fixed positions. They're always moving, so they move randomly around the nucleus. Again, the only thing that determines the chemical property is atomic number. Not atomic diameter, chemical symbol, or mass number. Only the atomic number, the number of protons. Now know this, memorize it. Protons and neutrons have equal masses, and electrons have 1 over 1840 of a proton. So just memorize it. So imagine this is two atoms, and they're asking the distance between the two nuclei. The distance between the two nuclei here, we have a radius, and then from the other nucleus we have another radius. 2r make a diameter, so the atomic diameter is the distance between two nuclei. It is in the order of 10 to the power of minus 10. You have to memorize 10 to the power of minus 10. Definitions. Memorize the definitions. A stable nucleus is defined as an atom that can exist indefinitely. Memorize the definitions, all of them. For this quiz, there isn't a lot of calculations, but it's like 5 questions, I think. What is the molar concentration of 1 decimeter cubed solution in which 0.5 moles of sodium carbonate is dissolved? We know C equals N over V. N is 0.5 and V is 1, so just 0.5. So equals 0.5. Two significant figures, 0.50. How many moles of sodium carbonate should be dissolved in 0.10 decimeter cubed of water to make a 0.5 molarity solution? N equals CV. C is 0.5, V is 0.1. You put it calculator, you get n equals 0.05, two significant figures, 0.050. For C, they're asking about the volume. They gave us moles and molarity. V equals N over C. N 0.1 moles and C 0.2 concentration, so 0.5. Two significant figures, 0.50. A student wants to prepare 100 centimeter cubed. Before we do anything, we convert this into decimeter cubed. We divide by 1000, so 0.1. Alpha 0.1 molarity solution of sodium carbonate. Find the mass of the sodium carbonate required to prepare the solution. We first find the moles. N equals CV. C is 0.1 and V is also 0.1. You multiply it, you get 0.01. So this is the moles. وبعدين you want the molar mass of sodium carbonate. If we go up, they give us the equation for it, Na2CO3. So we got the moles is 0.01 and the equation for sodium carbonate is Na2CO3. Na is 23, two atoms, so 223, plus C 12, plus 3 16 for oxygen. You put all of this in the calculator. You get 106 multiplied, and then we know that mass is moles times molar mass. You multiply the moles 0.01 times molar mass 106. You get exactly 1.06. And they said three significant figures. It's already 3, so that's your answer. We've been doing this for the last 2 weeks. Mg2 and O2 minus. They want the equation for it. Exact same numbers, opposite charge. They just cancel. MgO, NH4 and Cl minus. Again, plus minus, they cancel. NH4Cl, Ca2 and N3 minus, so crisscross. You bring the 3 to the Ca, so Ca3, and the 2 for the N, so N2, Ca3, N2. Al3 and SO4 2 minus. Again crisscross. You bring the 2 down for L, 2, and then for SO4 you bring the 3 down, so SO4. Now the 3 is for the whole ion, so we put brackets 3, Al2 SO4 3. So we took this week that the A is the mass number and Z is the atomic number. So the letter A in the atomic symbol represents the mass number and Z is the atomic number. Consider the atomic symbol of bromine. Now we have mass number is 80 and atomic number is 35. So they want the number of protons. The atomic number is 35, so you put 35. Number of neutrons. So to find the number of neutrons, you do mass number minus atomic number. So you just get the bigger number and subtract the smaller number from it. So 80 minus 35 equals to 45. So that's your neutrons. Number of electrons. Now number of electrons depending on what charge they give you. Here they didn't give us any charge here, so 0. So 35. To get the electrons, it's always atomic number minus charge to get the number of electrons. So atomic number is 35 minus charge 0, so 35 electrons. Question 11. So they gave us the symbols and they want the number of neutrons, protons and electrons. 3517 Cl minus. We first want the neutrons. We said before, big number minus small number, 35 minus 17, and it's equal to 18. Now protons, the number that's down, so 17. Electrons, I told you in the last question, you get the atomic number minus the charge. The charge here is minus 1, so 17 minus minus 1 equals 18. For the second one, aluminum 3 plus. Neutrons, 27 minus 13, big number minus small number equals 14. Protons, the small number 13, and electrons, 13 minus the charge 3 is equal to 10. Last, the one before the last, 23 11 Na plus. Neutrons, big number minus small number, 23 minus 11 equals to 12. Protons, the number that's down, or the small one, 11. And electrons, 11 minus plus 1. So this plus you don't have to put it, so 11 minus 1 is 10. And the last one, 3216 S2 minus. Neutrons, 32, the big number minus small number, 16, equal to 16. Protons, the small number 16 here, and electrons, 16 minus charge is negative, minus minus 2 equals to 18. For the first one, they're asking for the diagram that represents atoms, not ions, not isotopes, atoms. So same number of protons and same number of electrons. Here in figure A, we have one proton, one electron, so it's an atom. B, two neutrons. Sorry, isotopes, I forgot. Isotopes can be atoms, بس المهم that the number of protons and electrons, they have to be equal, so the charges cancel. So basically a neutral one. One proton, one electron, they cancel, correct. One proton but no electrons, فit's wrong. One proton and two electrons, still wrong برضو. Two protons and two electrons, so correct. So the diagram that represents atom A, B and E. Part B, they want the positive ion. We said this is an atom, this is an atom, this is an atom. So figure C, one proton, no electrons, so the charge is +1. Figure D, one proton, two electrons, one of these cancel, so we're left with one electron, the charge -1. So the positive ion is C. Choose the diagram that represents a negative ion. We just said this is an atom, this is an atom, this is an atom. We see is a positive ion, so the only one that's left is D. The number of proton of an atom is represented by its atomic number, proton atomic number. على طول, just memorize it. Where they want atomic number 2, so 2 protons. Atomic number, protons. This is 1 proton, so atomic number 1, wrong. 2 protons, atomic number 2, correct. 1 proton, so atomic number 1, wrong. And also 1 proton, so atomic number 1, wrong. So this is the only one that's correct, 2 protons. The mass number indicates the number of protons and neutrons. So when you see protons alone, it's atomic number. When you see protons and neutrons, it's mass number. They want this. They want the diagram with the symbol 2,1x. So we know from 2,1 one proton, and 2 total particles in the nucleus. So here we have 3 wrong, 2 correct, and 1 wrong. So 2 particles inside the nucleus itself. So this is the only correct one. This question, they're asking for the moles of ions. First, you write the equation. CrNO33 produces Cr3 plus and NO3 minus. Now we check if it's balanced. We have one atom, ion of Cr in the reactant side and 1 in the product side, so it's balanced. 3 NO3 is 3, and in the product side it's only 1, so you have to put a coefficient 3. We go back, check if Cr is balanced, still 1 and 1, we didn't do anything to change them, so now it's balanced. Now they gave us 0.5 moles of CrNO3, and to find the moles of the other ions we just multiply by the coefficient. For Cr, coefficient is 1, so 1 times 0.5. For NO3, coefficient is 3, so 0.5 multiplied by 3. So for Cr3 plus, it's 0.5, 2 significant figures, 0.50, and 3 times 0.5 is 1.5, 2 significant figures to 2 significant figures. Now to balance dissociation reactions, you just put the coefficient. You just turn the subscript into a coefficient. Here Fe doesn't have a subscript, so there is no subscript here. Cl has 3, so we put 3 in the coefficient. That's it. Atom, whenever they tell you nucleus is positively charged and around it is the electrons. So atoms have positively charged atoms have a positively charged nucleus around which negatively charged particles called electrons. And B, atoms have diameters in the order of 10 to the power of minus 10. I told you memorize this, in the order of 10 to the power of minus 10. The The nucleus is positively charged because it contains positively charged particles called positively charged particles, protons, and neutral, so neutrons. It's in the name. Positively, protons, neutral, neutrons. Gaining electrons, so مثلا you have the positively charged nucleus, مثلا 2 protons inside and 2 electrons outside. Now it's balanced. The charges cancel, but if we add one more electron, then it's going to be three electrons and only 2 protons, so the charge is -1. So they form negative ions by gaining electrons. Now imagine it's balanced again, and then we remove 1 electron. Now the charge is only one of the protons cancelled with the electron, so now the charge is +1. So positive ions by losing electrons. Memorize this. Protons and neutrons are made of quarks. Again, there is a lot of definitions in this quiz. You have to memorize them. So, protons and neutrons are made up of quarks. Nitrogen has 7 protons and 7 neutrons. They want the symbol of nitrogen with 7 and 7. So, nitrogen, we know it's N. 7 protons, so we put the 7 down. And up here is the mass number. So we add the protons and neutrons, so 7 plus 7, 14. They want the symbol that represents the number of nucleons. Number of nucleons is just mass number. So it's A, the one on top. Crystallization is the separation technique used to extract a substance from a mixture. We know that crystallization, the only thing that we can separate it from soluble solids. Other than that, we use any other thing. So to use crystallization, you have to memorize the apparatus needed: wire gauze, evaporating dish, Bunsen burner, and beaker. You have to memorize these. Now we know in crystallization, we never heat the mixture until all of the water is evaporated. We leave only some water in it, and it dries naturally, or we heat it over a water bath. So boil the mixture till all of the water evaporates? No, till most of the water. If it was most, it would be correct, but they said all, it's wrong. Heat the mixture aside until crystals settle at the bottom of the beaker. We don't want to see crystals while heating it. We need to wait for it to heat by its own. Warm the solution over a steam bath. Yes, we need to do that. Leave the solution overnight till all of the solvent evaporates. Yeah, we leave it all night or overnight or whatever you want. Just leave it alone to evaporate. Heat the solution till most. See, most. So it's correct. Filtrate. We're talking about crystallization, no filtration, so it's directly wrong. For this question, a student is asked to calculate the number of moles and atoms in a sample of 17.6 grams of propane. So first they want the moles. We know moles is mass over molar mass. Mass is 17.6, and C3H8, 3 times molar mass of C is 12, so 3 times 12 plus 8 times 1, so 17.6 over 36 plus 8 equals 44, and then you divide it to 0.4, 3 significant figures, add 2 zeros. Now atoms is equal to moles times Avogadro's number times atomicity. N, the number of moles, 0.4. Avogadro's number is 6.02 times 10 to the power of 23, and atomicity is 11. You put it in your calculator. You get in the calculator after we do N times Na times Avogadro times atomicity. You get in the calculator 2.65 times 10 to the power of 24. It's 2.6488 times 10 to the power of 24. They said three significant figures, so we round it up, so it's 2.65 times 10 to the power of 24. Here they're saying 2.64, but they accept 2.65. Just put 2.65 علشان it's the correct answer. So here they're asking for the moles, and they give you the number of molecules. Number of moles is number of molecules over Avogadro's number. So we put the number of molecules 9.0 times 10 to the power of 21 over Avogadro's number 6.0 over 10 times 10 to the power of 23. They gave it to you. You put it in your calculator. You get 0.015. And they said scientific notation and two significant figures. So we move it forward 2 times. So 1.5 times 10 to the power of minus 2. And then how many grams? We got the moles. So grams mass equals moles times molar mass. O2, so molar mass is 32, and we got the number of moles 1.5 times 10 to the power of minus 2. So you put it in the calculator, you multiply, you get 12 over 25 or 0.48. It's exactly 0.48. Two significant figures. You can put it scientific notation or put it the same, they accept both. Now they want us to balance H2O2 liquid produces H2O liquid and O2 gas. They want us to balance. H is balanced 2 and 2, so H isn't balanced. But O isn't, it's O 2, so 2, and 1 and 2, so 3. So you only want one atom after this, so you have this one, so you get a fraction. But you cannot have fractions, so you multiply the whole thing by the denominator, so 2. So 2 H2O2 liquid produces 2H2O liquid plus O2 gas. Again, here they want us to balance. They gave us the equation thing. So we do between 3 and 2, it's always 6. Don't forget it. 2 and 3, it's 6. To make this 6, we put 3 here and 2 here. Now Cl is balanced. 2 Fe, 1 Fe, it's not balanced, so we put a coefficient here. That's it. And then for part B, how many moles of chlorine are needed to produce 6 moles of iron 3 chloride? So you need to find you need to do RRGR. So RRGR. So they gave us 6 moles of iron chloride. So the product, so 6 moles. And they want us to find the amount of chlorine, so X. And the RR, 3 moles of chlorine and 2 moles of iron chloride. You cross multiply. 2x equals 18 and x equals 9. Two significant figures, so 9.0. So this is the whole quiz. Good luck in the CA, and bye.